Swayam Prabha. Digital India. Educated India.
I can briefly introduce you to Vensim. Vensim is a software we can use to simulate system dynamic models. If you put the underlying equation and click the run icon, the one shown here, guy running, it will run the simulation. If you don't put the equations, you can still draw some nice diagrams like like causal loop diagram, etc. There are nice arrows, etc. It can help you do that. This is one of the most simplest interfaces I have seen. Though there are many icons, the icons of interest are what is highlighted there. So there is a fourth icon from the left, 1, 2, 3, forget it, nothing. This is just lock screen, this is just to move things around. This one, which has a pencil and alphabets VAR, I think, VAR. We use it to define auxiliary variable. And there is a pencil with a rectangle with VAR written, that is to create a stock. And then one arrow link to create a link, that is a causal link. And a double headed arrow with a valve symbol that you just saw, whatever we have been using. The same thing is used to define a rate link. That is exactly what we need, we do not need anything else. All other things are for just visualizing, deleting and things like that. This is like the Pac-Man thing to delete, not needed. So this is the entire thing you will ever be using for building models. Apart from Vensim, there are other softwares like iThink, PowerSim. Software name is iThink, I am not thinking. iThink, PowerSim, AnyLogic, etc. So the symbols may be slightly different, but you just look for, if they use the variable rate, some may use the term flow rate, some may use the term level instead of stock. But usually they have a symbol, come on, rectangle, how? There are so many ways only you can draw a rectangle. So they will have that, or double headed arrow will roughly be the same with a valve symbol. Maybe they get more graphic with the symbol of the valve, but pretty much this one. And once we simulate, we will be using the icons on the left side to visualize the output. You just click the variable, click that graph symbol, you will get a graph immediately. And if you, so these first two are for the graphs, the next two are for actually seeing the values that are simulated. So once you get the actual values, you can see and understand what is the computation happening, or sometimes you will get to simulation, because this is just numerical integration, nothing else, it is just numerical integration. So sometimes it will say out of bounds, or values too high, or value crosses 0. So then you can actually see the numbers and see where it happened and what is happening and things like that, or you can copy paste it into Excel to get better graphs for the system. So there is a free software, the student version is free, you can download it from vensim.com. You have to go register yourself, give your email ID, they will send you a link, then you download the software. Yeah, so we will be using this in this course. Yeah, this is a Vensim interface. You click downloads and go to free downloads and go for the Vensim PLE. It works only on Windows and Mac. If you have Linux laptop, install Wine, it works fine in Wine, no problem. Yeah, you just fill the details, click download, you get the software. And that is sufficient for our course purposes. Looks like I downloaded a slightly new one. See here already it is different from the picture I showed in the slide, and apologize for that. It explicitly says variable, level, arrow, rate, better symbols. So we will just go with that. Simulate is the play button here, and left side these are all the images. Looks like that picture is of an older version of Vensim. So this is more clearer. The first we do is when we create a new model, the only thing it asks is initial time, final time, time step, and what is the general time units that we are looking at. let us say we are going to model this interest rate example. So, we want to keep the say time units as year and say time step as 1, final time there it was 15. So, let us take it say 20 time units to the time step of 1, click OK, you get just a blank screen. So, we had one rate, one flow, say same thing, one rate, one stock and auxiliary variable. So, first always put the stock, it is easier, I will tell you why. And then you put a rate. So, all I did was, I did not draw anything, I just clicked it somewhere and just wrote the name, it gave the rectangle, there is no right click, left click, just one click. And then you click rate, then you click, we wanted to go the direction. So, start point to end point, start is outside the system, you click somewhere there, there is no, I am not clicking and dragging, then you just move it and somewhere inside the stock, again make one more click, then it will ask the name of the variable, net, that is called net income, and you got this stock diagram. If you do not click it inside and if you click it somewhere outside, then the cloud will appear on both ends, like this rate, if I click it here and click it here, so call it, then I get cloud on both sides. So, sometimes it happen this and suppose it goes very here and click it, okay, this is connected, but sometimes it may not connect. I am just going to delete this, all these. So, this is a delete button and I want one variable, that was interest rate, then move our size by moving it here, arrows, again same thing, I click on inside the variable name, and to get a curved arrow it has a nice feature, you click it somewhere in the white area and then you click the next variable name, it will give you a curved arrow, principal, then again white area, then I do this, I get a nice curved arrows. We will have a specific exercise for that next week, so just observe. Then we give values for each equations, you have to click equations here, then everything in black means you have not given any equation further. So, let us go to principal, it already shows integration of net income, I am already integrating net income, so I have nothing else to add there, the initial value we told is 100. The main thing we need to write here is what is the units, so that I can do the units check. So, units here is, let us define it as rupees, RS. So, that is a unit, that is only thing I added here and added initial value 100, I click OK, this became white, it means some equation is put. Whether equation is right or wrong, it will not tell, there is something written there as part of equation. And let us go to interest rate. Interest rate is a constant value, so let us just put it as constant 0.15 and units is 1 by year, time unit is year, the fraction thing is just 1 over year, and I go to net income and in an equations I have to multiply interest rate into principal. So, on the big box here you see all the variables which is flowing into this variable, which is connected to this variable. So, you need to form, in this case interest rate and principal, both the values are coming to the net income. So, I need to form an equation considering both. Suppose I skip one, I just put interest rate, it will say following input is not used, but was expected. So, then you know you have a causal link, then you can again go back and then multiply it, add it, and units of this will be rupees per year. Okay. So, that is it. Then if you go to model, say units check, okay, first save it, all units are okay, good. Then you go to model, check model, model is okay, else it will show there is a type mismatch, units mismatch, or some variable is connected, you forgot the equation, or some variable is defined but it is not connected to anything else, whatever errors it will just show. So, once we do that, we just click the simulate button. So, I just simulated it. The simulation is done, it does not take so long to simulate, so you can simulate it again, override the data set. So, in principle, now I want to see what is happening. I just clicked it, then it becomes whatever is selected, it will be black, right. Suppose this is what I want, I click this graph and I see the graph for the system. Nothing, as I resize it, it automatically rescales it for you, or some legends come. If you want to see the underlying values, then I click this one, then I can exactly see the values what is being computed, right. I can look at other graph also, net income. This is one interesting thing. Suppose I click this one and I click causes strip, it shows how that variable changes along with all the variables which are acting as input to this. Stock is only affected by the flow, so by one flow in this case. So, that stock and how the corresponding flow is happening. So, sometimes it is useful to see all these things together, so that you can compare, and we can create much more complicated graphs that even if it is not connected, you can select them, visualize it. We will learn some of those features later. For modeling per se, that is it, it is not too difficult, people can do it. Difficulty is finding the equation, but drawing it per se, it is as simple as what you thought.